Find the area bounded by the curves y equals negative x squared plus 4x and y equals x minus 2 to this times the square root of x on the interval from 0 to 4. Okay, so this is a bounded area problem. So we have probably one graph on top, one graph on bottom. Find the area between the two. Not too bad. We can do this. Okay, so the hard part here is going to be figuring out the graphs. So this is probably the kind of problem you'd have with a calculator. But it's always kind of nice to start it off just kind of looking at what's going on, just to kind of get an idea of where you're at. So we have negative x squared, so it's going to be some sort of a parabola, and the plus 4x will make it bigger. So let's see, where is it? And it equals 0 at 0, and then at x equals 4, it'll be 0 again. So you'll probably have something kind of like this. And then for this guy, yeah, I don't know. So 0, when you plug in 0, you'll still get 0. I think so. Yeah. And then you have x equals 2 square root of x, x to the... I don't know. Maybe, why don't we plug in... So 4 equals 2 times the square root of 4, so it'll be here as well. So maybe we have something kind of like this, maybe? Let's check the calculator. Whoop, on, clear, move down slightly. Y equals negative x, nope. Delete x squared plus 4x. Didn't get the delete in there, okay. Negative x squared, okay. And then we have x minus 2 second square root of x close parentheses. And let's see here. Let's say window is, we'll go negative 1 to 5, even though it's 1 to 4, or 0 to 4. That way it'll give us a little bit of buffer on each side. Help with the visuals. Say negative 3, maybe. We can always adjust it later, so we'll guess and check. This is one of the reasons I don't like to use the calculator, because it just takes so much time. 6. Maybe. Graph. Okay, there's the top one. Looks like, yeah, yep. And then, looks like we were kind of sort of mostly correct on most of it. It's pretty good. It's pretty good. Good for us. Okay, so now we have this graph is there. That graph is there, but also there. So to redraw everything, because I've already made a terrible mess of this, let's go with light blue. Graph. We have y equals negative x squared plus 4x. Graph. We have x minus 2 square root of x. Y equals. And we're going to find the area of the top curve minus the area of the bottom curve. And when I say area of, what I really mean is integral. Whoop. Green. So integral negative x squared plus 4x dx. This will be from 0 to 4 minus integral x minus 2. I'm going to write this x to the 1/2 just because it makes it more obviously the power rule. Easier for me to visualize. Then I will distribute the negative. And this will be 0 to 4. We can then combine the integrals. And we will get, change colors, negative x cubed over 3 plus 4x squared over 2 minus x squared over 2 plus 2x to the 3/2 times 2/3. Okay? This will be evaluated from 0 to 4. We then have, let's see, we'll simplify things slightly. Yeah, back to green. Negative x cubed over 3, that'll stay the same. But now we'll have plus 2x squared minus x squared over 2. So we can change that to, let's see, 3/2. Is that 3/2? That's 3/2. 1.5. So we'll do 3/2 x squared. Plus 3/2 x squared. 2 minus 1/2. plus 4/3 x to the 3/2. I'm going to evaluate from 0 to 4. I'll quickly look at the 0 portion right there. We know that when we put 0 in for everything, it's going to be 0. So I'm not even going to bother doing the 0 portion because we know it's going to be 0. Now for the 4. So negative 4 cubed. So 4 times 4 is 16. 16 times 4 is 40 plus 24. So it'll be 64. So it'll be 64 over 3. I don't like thirds. Plus 16. Alright, times 16 plus 4/3. So 4 to the 3/2. So the square root of 4 is 2. 2 cubed is 8. So it looks like we're going to be going with 6's here as a common denominator. So negative 64 over 3 plus 32 over 3 plus 48 over 2. Okay, so this will be 48 over 2 minus 32 over 3. Not sure if I want to multiply these. So we'll do, yeah. Is there an easy way? No, I don't think there is. Maybe there is. Maybe. Okay. So you could just do this with your calculator, and that'd probably be fine. So we have 24 minus 10 2/3, which will equal 14 minus 2/3, which will be 13 1/3. So 13 times 3 is 39. 39 plus 1 is 40. So our final answer will be 40/3. I think that's right. Maybe? Let's take a... Aha! It's even a possibility. Yes! Go us. Feels good, very triumphant. Okay. So I'm going to confidently say yes. 40/3 is the answer. So to backtrack, that was kind of a wild journey with a whole lot of uncertainty. So let's backtrack and see where we went. So we're given these two graphs. Not quite sure what they are, but we see that one is negative x squared. So it's like, well, probably an upside down parabola, more or less. And y equals x minus 2 square root of x. Well, I was thinking, well, maybe it's kind of a line. Maybe it's kind of a square root of x. Meh. We're not really sure. We plugged in 0 and 4, the endpoints, and we got 0 for both of them. So that kind of makes sense. And for the most part, we gave up at the end and put it all into our calculator. And our calculator gave us something kind of looking like this, where the top graph was negative x squared plus 4x. The bottom graph was x minus 2 square root of x. And they intersect at 0 and 4. So we can do the top graph minus the bottom graph, and that'll give us our total area. The integral of the top graph minus the integral of the bottom graph. So we write that out. It turns out it's just a whole bunch of power rule, which is fine. We do the power rule. We evaluate from 0 to 4. The 0 kind of goes away because everything has x. And then we're left with trying to rationalize it. Combine denominators, which is mostly just lots of algebra, which, you know, not particularly, it's not complicated, but it is cumbersome. And we work our way through there, and finally we get to 13/3. No, we got to 40/3. And that was our final answer. Thanks for coming along. I will see you on the next problem.